Hey guys, welcome to FM342 of the Further Maths Fortify study guide. This question reads, Max is building a shed to house all his tools. The front face of the shed is a trapezium with an isosceles triangle cut from the top as shown in the figure below. And then we're given a figure that looks like this one. Max is installing two lights, one at point A and one at point B. The trapezium has a width of 5 meters. The trapezium has a major height of 3 meters. And a minor height of 2.55 meters. The triangular cutout has side lengths 2.83 meters here and here, and then one unknown side length up the top. Question A, part I, or part 1, says, show that the straight line distance in meters between the lights at point A and at point B is 5.02 meters when rounded to 2 decimal places. So the way we're going to break this down is actually by creating a right angle triangle. So we have something that looks like this between point A and point B. So we're taking sort of a straight edge and cutting it out and using this, this dotted line as our hypotenuse for our right angle triangle, which means that we have down here a distance of 5 meters, as the trapezium is 5 meters wide. Up on this side up here, we're going to have the 3 meters minus the 2.55. So whacking that in your calculators, you get 0.45, like that. And of course, we're being asked to find this length here, the hypotenuse, or the straight line distance between A and B. So we've got 2 known side lengths and 1 unknown, which means we can use Pythag to figure this out. So we're going to use c squared equals a squared plus b squared. I like the rearranged formula, c equals square root of a squared plus b squared. Substituting our numbers here, we should get our unknown is equal to the square root of 0.45 squared plus 5 squared, which should give an answer when rounded to 2 decimal places of 5.02 meters. Cool. So that's part I. II then goes on to say, using the cosine rule, show that the angle theta, correct to the nearest degree, is equal to 125 degrees. So this time, I'm going to take this cutout triangle. So we're being asked to show what this angle is. We've now figured out that this is 5.02, 2.83, and 2.83. Now the cosine rule that we'll be using is to find this angle. So the stock standard version is cos of A should be equal to b squared plus c squared minus a squared all over 2bc. Rearranging this a little bit, we get A is equal to cos -1 of b squared plus c squared minus a squared all over 2bc, like that. Substituting our known variables into that, we get theta should be equal to cos -1 of 2.83 squared plus 2.83 squared minus 5.02 squared all over 2 times 2.83 times 2.83. Whacking that into a calculator and rounding to the nearest whole degree should give you an answer of 125 degrees. We're then given a little more information. We're told that using this front face design, so that we've found here, Max plans to give his shed a depth of 5 meters as shown in the figure below. Now I haven't drawn this figure, but it would look a little something like this. Where of course this is 5 meters deep. Last line, a bit throwy, there you go. So it's going to be 5 meters deep. B asks us, what is the volume in cubic meters of Max's shed? Round your answer correct to the nearest cubic meter. So this one may seem pretty tricky, but it's not too bad once you put it all together. What we need to do is find the area of this front face and then just multiply that by the depth of 5 meters. So if we can find this area, we're in business. So the way we're going to set this up is that the area of the face, the volume is going to be found by finding the area of the face and multiplying that by the depth that we've been given of 5 meters. So the trick here is going to be in finding the area of the face. Now the area of the face is going to be equal to the area of the trapezium minus the area of that triangle. So we're going to find the whole area of this, and then we're going to subtract the area of that triangle there. Triangle. Cool. So the area of the trapezium we're going to find by using a plus b over 2 times height, where a and b are the 2 different side lengths. And in this case, the height isn't actually going to be a height at all. It's going to be this base length. But of course, it needs to be perpendicular to those 2 lengths there. And we're going to subtract the area of a triangle. Now, the triangle that we've got here, or the information that we've got, means that the formula that we'll use to find this triangle is going to be half AB sine theta, because we have 2 side lengths and an angle. So it's going to make it nice and easy for us to find the area of this triangle. Substituting all of our known values in, we should get, for our trapezium, 3 plus 2.55 all over 2 times 5. That should give us the area of our triangle, of our trapezium. And then we're going to subtract the area of our triangle, which should be half times 2.83. Now it'd normally be times 2.83 again, but because they're both the same, I'm just going to make this squared times sine of 125, since that's what we found angle theta to be. Cool. So now we've got an expression for the area of our face. We just need to multiply this whole expression by our depth. So our volume, if we lump it all together, is going to be equal to our 3 plus 2.55 all over 2 times 5 minus half of 2.83 squared times sine of 125. And all of this is going to be multiplied by 5 to give the volume. Whacking that into your calculator and then rounding to the nearest cubic meter, we should get 53 meters cubed. If you guys have any questions about this question, please leave them in the comments below. Otherwise, I will see you in the next video.